Alright guys, this is lesson 7-3, which is titled Perpendicular Lines. So, this is the last lesson for activity 7, and in this lesson we'll be dealing with obviously perpendicular lines. So we've dealt with parallel lines and their angle relationships, and we'll still use that a little bit, but now we will be dealing with perpendicular lines. So, let's go through what the learning targets will be. First learning target will be to develop theorems to show that lines are perpendicular. So we're going to be doing that and adding theorems to our list of justifications. So I'll go ahead and we'll circle develop. We're developing theorems, and these theorems will show that lines are perpendicular. And then we'll also determine whether lines are perpendicular. So we'll use these theorems that we develop to determine if lines are perpendicular or not. All right, let's do it. So we have our term for perpendicular lines. We know that two lines or parts of lines are perpendicular if they intersect to form right angles. So we have two lines, say, that are intersecting. If they form right angles, then they are perpendicular, okay? So that's pretty much it for that. They can also, doesn't have to be like two lines forming four angles. You can also have them like this, like a line. Two segments like that, then you would only form two perpendicular angles. All right, so go ahead and add this definition of perpendicular lines. Add definition of perpendicular lines to your list of justifications right now, please. All right. We have a second customer for Madeline's patio stuff, and so she's hired the company, has hired a second customer of Patios by Madeline has hired the company to build a patio with rows of bricks that are perpendicular to the walkway. Okay, so this time we have the walkway is perpendicular to the bricks rather than parallel like the last time. Matt is planning the design for this patio. So far he has extended a line along the walkway and labeled points X and Y to mark stakes at the edge of the patio. He has also drawn point W to mark another stake at the edge of the patio, as shown below, which we'll see that on the next slide. Okay, so let's move on. So before we get to that, actually, we're going to go over two postulates that I want you to add to your list as well. So first is the perpendicular postulate. It says that if a given line and a point not on the line, so I have a line, and then I have a point that's not on the line, then there is exactly one line through the point that is perpendicular to the given line. What that means is that I have to have this line that I want to draw has to have two conditions. That's perpendicular to the original line and it goes through this point. The perpendicular postulate tells us that there's only one choice for that. Okay? Meaning that I couldn't draw another line that would also be perpendicular. If I drew another one and that intersected this line, it would not intersect at a 90-degree angle. It would not be perpendicular. It just means there's only one, which is very useful and nice. Okay? Likewise, the parallel postulate states that if a given line and a point not on the line, then there's exactly one line through the point that is parallel to the given line. Meaning I can only draw one line through this point that's parallel to my original line. Okay? That's what that says. Go ahead and add both of those to your lists if you don't mind. So you add parallel postulate and perpendicular postulate to your list of justifications. Okay, so moving on. Now we're back to the image that we were talking about earlier about what Matt has done. He hasn't made the patio, but this is what he's drawn out so far. He's drawn a point W on the outskirts of the patio, and he's also drawn a line all the way, extending the walkway all the way through, and it's signified by points Y and X, okay, for each boundaries of the patio. You're going to need a protractor for this question. So what I want you to do, I want you to work out numbers 1 through 3 on your own. I know it's work 1 through 3 on your own. Pause the video and then we'll explain them. All right, so using a protractor to draw the line perpendicular to line XY, that passes through point W. Label the point at which the line intersects line XY at point, label it point Z. Excuse me, I can't talk today. So that's what I did. So we got to use our protractor. What you need to do this, you're going to take your protractor and you can put it on the line XY, okay? Kind of shift it around until the the 90-degree part of the protractor lines up with our point W, okay? And then you will you can draw a line straight through it. It's just, we just want it to be 90 degrees, right? We want it to be 90 degrees. Or you could also actually do it another way too. You can put it, and you can put the protractor like this. Excuse me. This and this way, and then wherever it lines up, you can use your straight edge to draw the 90-degree angle. So doing this is what I got. We got our perpendicular. Mine looks a little less than perpendicular, but it's meant to be perpendicular. So perpendicular means that it's going to be what, right angle. So the square, make sure you draw that square in there, okay? All right, so remember it intersects at point Z. So that's that. That's number one, guys. Number two, use your protractor and your knowledge of parallel lines to draw a line across the patio parallel to WZ. Explain how you know the lines are parallel. So, here's what I did. I drew another line, okay? Remember, they are both perpendicular. It says explain how you know they're parallel. We know they're parallel because these two angles are corresponding angles. So let's call this point A. So how about call this D. So the measure of angle YZW is 90 degrees. Measure of angle YAD is also 90 degrees, right? Okay. So angle YZW is congruent to angle YAD, and they are corresponding angles. So angle YZW and angle YAD are corresponding angles. So we can say that they're parallel by the corresponding angle, the converse of the corresponding angle postulate that we did in last section. Remember, because if we know that two lines are cut by a transversal, or if we have and the corresponding angles that results are congruent, then the lines are parallel. So we can say that those two lines are parallel because of that. And that's from last section. Okay. So I'm going to erase this now. Describe the relationship between the newly drawn line and the line XY. Well, let's think about this relationship. They're perpendicular, right? They're perpendicular because those are parallel, you know. So, and that's why it's perpendicular. They're perpendicular. We kind of talked about that in question 2. So, I have another new theorem called the perpendicular transversal theorem. It states that if a transversal is perpendicular, okay, so to one of two parallel lines like this, then it's perpendicular to the other line. What it means is, say if it's perpendicular to this one, these are parallel, then it has to be perpendicular to that one as well. And we're going to go through a short little proofish thing of that. So in number 4, so what I want you to do, go ahead and pause your video, work number 4 on your own, and then make sure you are drawing a picture as well for this one, okay? All right, so Matt reasons that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Show that Matt's conjecture is true and include a diagram in your answer. So this is the diagram I have, or excuse me. So you have this math tip. I hope you read that because it's not bad, but just go ahead and read over that math tip as well for yourself. So here's the diagram I chose though, okay? I drew that. Kind of like the one I just drew. So I've got line M and N are two lines that, two parallel lines. And then T is the transversal of those, okay? And they form angles 1 and 2 is what we have labeled here. So in the diagram, M is parallel to N and T is perpendicular to M. Okay, so we know that. All right, angle 1. So measure angle 1. And by the definition of perpendicular lines, angle 1 has to be a right angle, right? It's a right angle because that's what perpendicular lines say. That when two lines are perpendicular, they form right angles. So the measure of angle 1 is 90 degrees. By the corresponding angles postulate, which says that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Angles 1 and 2 are corresponding angles, so they are congruent as well. So angle 2 also measures 90 degrees. Okay. Since angle 2 is a right angle, by the definition of perpendicular lines, T is perpendicular to M. Right? Since this is a right angle, they intersect at right angles. It's also perpendicular to M. So this was kind of an informal proof of the perpendicular transversal theorem. Basically, we didn't do a two-column proof. We just kind of worked through it and talked about it in steps like that. All right. I want you to add the perpendicular transversal theorem to your list as well. Okay. This is very useful when it makes sense. If they're two parallel lines and they're cut and one's perpendicular, the other one's got to be perpendicular. That's essentially what we're saying. Okay. All right. New term, a perpendicular bisector. So a perpendicular bisector of a segment is a line or part of a line that intersects the segment at its midpoint to form right angles. So if I've got this segment right here, and then I've got a line going through it exactly at the middle, at the midpoint. This line right here, the one that's a line, that is what we call the perpendicular bisector of the segment, okay? If a line is the perpendicular bisector, it's not the one being split in half. The segment is being split in half at its midpoint. Okay, so let's look at some. Please go add definition of perpendicular bisector to your list of justifications, because you'll be using that one for sure. All right, so number 5. What I want you to do, pause your video and do number 5, please, and attempt it, and I'll go over it in a sec. All right, so Matt draws segment AB on his design of the patio. So I have the design of the patio above this question right here. He draws it so that line XY is the perpendicular bisector of segment AB. Okay, line XY intersects AB at point M. And we're going to list 3 conclusions that we can draw from this. So I've gone ahead and drawn some segment here, but they weren't specific how they wanted it, so I did. The only specific thing we know is that we have to have a midpoint M. Right. So it intersects at the midpoint. I'll go ahead and do it like that. Midpoint M. Okay. So we draw that on there. We want to list what we can conclude from this. First thing I'm going to say is that line XY and AB intersect to form right angles. We know that because of XY is the perpendicular bisector. That's important. So we know that they form right angles. So I'm just going to draw 4 right angles right there, right? Point M is the midpoint of AB. That's just by the definition of perpendicular bisector, but it's the midpoint of AB, not of XY. XY is a line, lines don't have midpoints, but it's the midpoint of AB. It's what's being split in half. Okay, since it's the midpoint, we can say that AM, segment AM, is congruent to segment MB, because when a midpoint splits a segment into 2 congruent segments. So you could have said some other conclusions from this one. If you have any questions about your what you wrote, and if they're right or wrong, we can talk about it in the question session, or you can shoot me an email as well. But this is what I have, okay? All right. Number 7. So we are now on the check for understanding in your book. I want you to do 7 and 8 on your own, please. I believe it's just 7 and 8, and then I'll go over it. So pause your video now. All right, so 7 says lines A, B, and C lie in the same plane. What does that mean? It means they're together, they're on the same plane. Yeah. If A is perpendicular to B and B is perpendicular to C, can you conclude that A is perpendicular to C? Explain, and then include a drawing to support your answer. So you should have had a drawing when you were doing this. If not, go ahead and draw it, what I do after we go over it. So this is my drawing here, okay? So I have A and C here, okay? Then I have B that is perpendicular to A and C. We want to know, is A perpendicular to C? It does not look like from the drawing, but let's explain why. So you cannot. A is perpendicular to B, B is perpendicular to C. So angle 1 and angle 2 are both right angles. Because of that, that tells us the perpendicular is what tells us that angle 1 and angle 2 are both right angles. And it means that they both have a measure of 90 degrees. So they're congruent, okay? They're also corresponding angles that are formed by line A and line B being cut by line C. Angle 1 and angle 2 are corresponding angles formed by line A and C being cut by line B. So line B is the transversal cutting A and C. All right? A and C have to be parallel, and that comes from the converse of the corresponding angles postulate. So since they're parallel, they cannot be perpendicular. So that's your explanation. That's good just reasoning right there. Okay? And then number 8. Segment RS is the perpendicular bisector of segment JL. Can you conclude that point K is the midpoint of RS? So, if you look at our drawing here, RS is the perpendicular bisector of JL. So we're going to say no to this. But why? Since segment RS is the perpendicular bisector of JL, okay, we know that they intersect at the midpoint of JL. That's important. Because RS is the perpendicular bisector, not JL is. RS splits JL in half at point K. We don't know if JL is the perpendicular bisector of RS, though. It doesn't tell us that. All we know is they intersect at point K, but that's the midpoint of JL. That's all we know. There's not enough info to claim that K is the midpoint of RS. It could be. We just don't have enough info right now to know, based on what we're given.